energy sector's future. We're pleased to have with us Julian Durand, who's here live. And Julian, you can come on out. And also online is Bruce Otte. I see you there, Bruce. Thank you for joining us. And Julian is InterTrust's Vice President of Product Management and Chief Information Security Officer. And Bruce is the Chief Information Officer of JERA Americas. The two will tell us everything we need to know to probably put us to sleep, right after lunch. I'm counting on you guys to keep that straight. But gentlemen, over to you guys. Enjoy.
Hello, everyone. Hello, and hello, IoT Live Slam 2023. I hope it's really going to be live and there aren't too many food comas in the audience today. I'm really thankful to SAS, our hosts here today, our organizers, Meshach and Kevin. They've done an incredible job, of course, and I'm really grateful to all of you to come here today after lunch. Hope we'll keep you awake. I hope you'll find this interesting. We really have some interesting news that we're really looking forward to sharing with you, Bruce and I. And so we'll start off with some simple introductions. Maybe Bruce, maybe you could start and introduce yourself and JERA.
Yeah, happy to do so. Julian, good afternoon, everybody, and welcome to the Live Slam here. My name is Bruce Otte, and I'm CIO of JERA Americas. And for those of you who are wondering, who the heck is JERA Americas? We are a wholly owned subsidiary of JERA company out of Japan. And in the US here, we own and operate today 14 power plants in the Northeast and in the Texas area, and that's continuing to grow. And around the world, JERA operates some 70 power plants. So really big into making sure that power is generated and available to be delivered to our consumers. And this particular session here is talking about some of the challenges we're facing as this operator of power plants across geographies as well as across regions within a single geography.
Great, thanks, Bruce. And who the heck is InterTrust? Well, I'll tell you, I fell in love with InterTrust, got to know them back in the 90s, when I was still an engineer before I transitioned to the dark side of product management. I was an engineer at Nokia, and I was the lead for the digital rights management, the content protection for Nokia's very first music phone, the Nokia 5510. And it was a really special phone because it was the first phone that enabled consumers to buy licensed content. And if you remember, as some of you may, back the late 90s, it was a really chaotic, turbulent, and value-destroying time for the music industry because of Napster and unlicensed content. And at the time, I selected InterTrust Technologies to be the exclusive content protection for Nokia because I found the ability of providing data interoperability and a common trust model would really enable and catalyze the licensed music industry. And fast forward to today, where there's been incredible blossoming of many options for buying content online, streaming content, common trust models, common standards for data interoperability. And that came courtesy of many companies, including InterTrust and standards like MPEG. And so back around 15 years ago or so, our CTO, Dave Mayer, who shared the stage before, he started turning his eye to the problems of fragmentation and siloed issues within the IoT, the lack of trust models, the lack of trust overall. And he started developing solutions and technologies to bridge these gaps. And he took great inspiration from the telecom industry. And the telecom industry was, at one time, before standards, very fragmented. I mean, does anybody here remember trying to send a text message from Verizon to AT&T? Hands up. Okay, some people do. And you couldn't send text messages from AT&T to Europe because there was a lack of interoperability, right? And who remembers going around the world with a suitcase of mobile phones because you needed a different mobile phone for every carrier you went to? I sure do. Who else remembers? You remember that. You do too, right? And that caused a lot of undue cost and a lot of threats to be applied to the system because the threat model was so vast. And what happened over time in the 80s and 90s, the group system for mobile, GSM, was brought together. And it brought together the world's carriers and the world's equipment providers. And ultimately, what they provided was a national standard and a national trust model, international trust model, so that you could roam with your phones and you could send a text anywhere in the globe. But more importantly, and I don't even know if people knew about the importance of this at the time, but it enabled equipment manufacturers to make one piece of equipment that they could sell globally. And that provided them tremendous cost savings. They also enabled them to apply a single trust model and really harden the systems. And that led to one standard after another, the 3GPP standards for fast wireless internet that's enabled all of our smartphones. Electronic SIM, you don't need physical SIM cards anymore. And the lack of not needing physical SIM cards anymore means that we can have cellular connectivity now in all sorts of very difficult environments, like a vehicle, shake, rattle, roll, dust, humidity. We're never good for a plastic SIM card. And so these standards not only lowered the cost of these systems, but enabled a common approach to have better security and better data interoperability to get out of these expensive and regional silos. And fast forward to today. Billions of people are connected to the high-speed internet. Over almost 3/4 of the world's population. Almost every country on Earth benefits from direct connections to the internet. Hundreds and hundreds and hundreds of operators share a common standard. And we've all benefited from all of that. And so it led us to think, what if we could apply this to today's systems? What if we could apply this approach of data interoperability and a common trust model to today's energy systems? What do you think, Bruce?
Well, I think that would be absolutely fantastic. One of the biggest challenges we face relative to being able to ensure that the power we're generating is that all of our sensors that we have across our fuel chain, across our power generation chain, and across the power delivery chain can interoperate and talk to each other. And right now they can't, right? Each of them are coming from different manufacturers with different standards those manufacturers are using. And because in many cases, hey, I've got a turbine at a couple of the plants that the turbine's brand new are $20 million, right? A replacement repair turbine's $5 million. These are big, expensive assets, right? So those manufacturers want to ensure that those assets are warranted, and we buy extended warranties from them. So they want to make sure the data associated with that is secure for them to be able to provide their warranties. But in the process, we're getting tied up with either themselves as a manufacturer or the software vendor they've worked with to try and create this data exchange, where we're having to pay different licenses then to be able to get access to that data so that we can then use that data to be able to optimize our operations across the entire ecosystem. And as we continue to move more to renewables, as we continue to move more to a blended generation of power, we're going to run into the fact that we need data to be able to drive this in the best way possible, all the way from the having the fuel in the right place for whatever fuel it might be. It could be a carbon-based fuel, it could be hydrogen ammonia, a non-carbon-based fuel, but you still have to be able to track that and process that all the way through to the delivery of the end home users, right? And the home users, many of them are wanting to get smart with their smart devices in the homes. And all of those are being set up with their own standards, which makes it tougher to have that interoperability. So coming together with some other folks in the energy industry, we decided to say, what can we do? And the idea came up that said, what if we were to create a standards board associated with the IoT data around energy across the entire ecosystem, from the fuels to the generation, to the delivery, to the home delivery, right? The transmission to the home delivery. And that's really what we are looking for with this particular HEA, or Trusted Energy Interoperability Alliance. Next page. And so the four companies that have come together to start this particular alliance, and it truly is just in its infancy. Press release went out the week before last, just announcing that we had come together to start to create the alliance. We're now out generating interest across the global industry. But the four companies are E.ON, large energy provider in Europe, Origin, very large energy provider in Australia and Southeast Asia, and then JERA. And I introduced who we were in the beginning and the volume of power that we're generating around the world. We combined up with Intertrust because they've been there before. They've done this before. And so working with them and their expertise is the goal to create a standard set that will allow us to be able to more readily manage our data and information. And so the idea is the more interoperable we have the data and the information, the more we can optimize our operations, ultimately delivering power to the right sources at the right moments in time, and at the same time optimizing costs and keeping those costs low not only for us, but the consumers of those electrons called electricity that we all survive on. So the challenges that we faced, right, are the OT, which is the operations technology, and the IT have been on different systems. But we've got to converge these together so that the guys who are looking at the data and making decisions are combined with the guys who are actually generating that data at the operations itself. So back to you.
Thanks, Bruce. It's a great introduction and explanation of some of the challenges. And it's really helpful to have Bruce, a veteran out of the energy industry that actually works and lives this day to day. And, you know, as we've worked more and more closely with JERA, with E.ON, Origin, other energy players, we've really come to realize that we're at a place now that is really quite analogous to how it was once in the music industry, before that was catalyzed by trust and interoperability standards, where we were in the mobile industry, before that was catalyzed by trust and interoperability standards. We have even more challenges today, I think, with energy, because the trust in this system is less about ensuring that people pay their mobile bills on time and that they're properly accounted for. It's even more fundamental and important to our society than ensuring that we all have wonderful content, music and video. Particularly since February 24th of last year, the world has been thrown into crisis with a lack of availability of fuels to heat our homes. I was in Austria not too long ago, and I heard a very interesting story in Vienna. Apparently, Vienna has a long tradition of progressiveness, over 100 years of progressive governments, but they live in a county that's very conservative. And overnight, the fuel that they use to heat their homes spiked by 2,000% in price because of the crisis. The city was going to go bankrupt. The city of Vienna was going to go bankrupt. And it was a terrible political crisis because the county, the conservative county, didn't want to fund that. And so they were literally dealing with a situation where they may not be able to heat their homes in the deep of winter. It happened in Germany, it's happened across Europe. And more fundamentally in our world, we're facing climate catastrophes every day. So we need to move quickly to green energy. The essential need to move to green energy, though, is difficult because renewables are by their nature distributed, which brings along a new threat model, larger attack surface, distributed systems. It brings problems of data interoperability because unlike the energy production and transmission and distribution and consumption in the old days, this is very much a two-way system with storage systems, production systems, localized and generalized. And the challenges there are absolutely data-driven. And the notion that we can run such systems with completely different silos, different equipment manufacturers having different data formats, having different trust models, having different protection mechanisms, not only increases the attack surface and the ability for state actors to penetrate and compromise our systems, but it also makes it just impossible to run these systems in near real-time ways. And so we believe that if we have a standard that goes from, as the chart here says, from the very origin, from fuel procurement through to generation, and that's wind, solar, also thermal. That will be a part of our mix for some time to come. The transmission, distribution, all need to be standardized. They all have to have a common trust model. You see all those lines in between, those are gaps. And gaps are really, really bad for security. Gaps are what attackers use to get in. And attackers today are incredibly sophisticated. Not only do they have world-class weapons of destruction in the form of automated exploit kits and reconnaissance kits, but they have a whole marketplace in the dark web where they trade and sell identities of people and identities of equipment. And so everything needs to be explicitly identified, and everything has to adhere to the same trust model. And that level of trust and encryption has to be common from the generation to consumption, and it has to be consistent. And so with that, we believe that it's not just defensive, although that's a critical thing. Does anybody remember the Colonial Pipeline? Colonial Pipeline was a big problem, but it was a weird problem. They shut down their OT network, their entire gas pipeline from the Gulf up to Boston, cut off millions of people from gasoline to power to everything. Everything shut down. But you know what's really weird about that? Is that it wasn't an attack on the OT infrastructure. It was actually a ransomware attack on their IT infrastructure. And the problem is that they believed, or initially believed, that their OT, their pipeline would be safe if they air-gapped it. And the trouble is, and this has been proven time and time and again, talk to the people at Department of Homeland Security. They do audits of this kind of stuff, and every time they go in and they do an audit of a system that's apparently air-gapped, they find dozens, if not hundreds, of connections between them. Why? Because it's easy. Everybody wants to run things like the IoT. That's what IoT Slam is all about. That's why it's been around for these 8, 9, 10 years, because everybody wants to run these things like computers, and we need to be able to achieve our green energy in a sustainable way to be able to save the planet. And so what if we could provide a capability to bridge that? What if we could provide a capability to bridge these OT systems and IT systems and feed our AIs with non-poisoned data so that we can actually have good, trustworthy, highly efficient systems? And that's what we're talking about with TEA. And so this little bubble down at the bottom that says energy services, we believe that with this common platform, just as has happened in the content industry and just as has happened within the telecoms industry, there will be a whole new range of services we can't even imagine. And those services will be for the benefit of personkind. Those benefits are going to go downstream to our edge devices. Our edge devices are getting smarter and smarter and smarter and more automated. We still have silos. Everybody heard about, I'm sure, GM and Ford signing up to Tesla's network of chargers, because that's one big silo and they had to join that. We need to move to a new landscape where we have standards for those energy chargers down at that consumer level. So we have end-to-end interoperability, end-to-end trust, and that will transform our energy systems. That'll transform our society. And so what we're going to work on is this: energy interoperability for a sustainable future. Data interoperability standards to scale, because we need hyperscale. This is a worldwide endeavor because we all live on the same blue ball. We need data security because the threats have never been so serious. And we need resilient, robust security, and that's going to be the core of this standard. We're going to have the best, most trusted model, and that's going to be bought into and developed by the world leaders in energy and equipment makers and innovators, and I really hope that this will be of interest to you all. This will be a standards organization over the next few weeks and months as we grow it. As Bruce said, it's just in its infancy. We just announced it with core partners that represent massive generation, massive buying power on the world stage. And these companies, JERA, E.ON, Origin, they're going to transform the energy landscape with us. And I really hope you come along for the ride. If you're interested, go to trusted-energy.org. And please see us at the Intertrust booth. Myself and Tony will be there, and we'd love to talk to you and tell you more about it. Thank you very much.
Thank you, everybody.